Hey guys, it's Brian, and welcome to part 4 of creating a Twitch game in Phaser. So where we last left off is we had our game running, but we had an issue with our player sprite not appearing properly. And we had been refactoring our player to be in its own separate class. I did a little bit of debugging off stream and basically figured out, although I'll be completely honest and say I don't know exactly why this fixed the issue, but what we're doing instead of extending the, if you remember, we had the I think .physics.arcade sprite class. Instead of extending that, what we're doing is extending the regular Phaser game objects sprite. And then from there, what we're doing is going ahead and adding it to the world via the scene, where we're basically saying, okay, we're passing in the scene to the player when we create it, and we're saying, and on the scene, the physics.world.enable this, which enables the physics simulation to happen on the player. And so this allows for collision and velocity and things like that. What I'm doing now is I was starting to move the enemies from a physics static group to just a regular group and basically have it operate the same way the player does, where we just add and enable the physics of the sprite to the scene in this manner. This is the part that I'm not sure exactly what the difference is and why it works like that, but that's how I got it working, at least having the player appear properly. So we're going to just go with that for now. What you'll notice, though, is because I have the enemies as a group that are not a physics group and I haven't enabled the physics on them, they don't have collision boxes, so the player does not collide with them. So let's go ahead and pick up where we're going to fix that issue. So what we're going to do here is actually refactor out the enemies to be a new class. So we can basically just go ahead and copy what we have here. And what we'll do is we'll say, all right, so this is going to be an enemy. Okay, that's fine. It does need HP because we're going to be fighting it. And it'll take in the same stuff. It'll just take in the scene, the XY coordinates to spawn it, and the key for the sprite. So this is still fine. The HP we're just going to set to 10 for now. Same thing with the player. We're going to enable it to have physics, and we're going to add it to the world through this method. So I think this might be a little bit different from what we did last time with the player. But this is how we're adding it to the world now, is in the constructor of the player class. Again, we have access to the scene, so we're just saying scene.add an existing item, which in this case is this referring to the instantiated player that's created in the constructor. So basically all that would be, that's directly equivalent to, and let's see if I can actually hopefully prove that. So if we look at create player and we say, okay, so we have a reference to the player, we could also just say, since we're in a scene here, we can say this.add existing this.player, because we created the player and we're going to add it to the world this way. Same exact thing happens, but we're going to actually have it be taken care of in, oh, well, I'm sorry. I forgot to actually take it out of the player class, not the enemy class. So, yes, the same thing still happens. The player gets created into the world, but we're going to actually have it be handled inside the player constructor. I like that a little bit better, I think, just because I'll leave it to the player class to be responsible for anything that is having to do with the player. So it makes more sense to me to have it there. So we can get rid of a log message there. And okay, so what we want to do is, instead of having the enemy be created directly in our scene, we're going to import our enemy, right, from sprites enemy. And we're going to go ahead and, I think we have a create enemy. Yep. So with this, all we're going to do is say this dot enemies, right? Because we're going to have a new enemy. Yeah, so we're creating, oh, okay, so, okay. All right. I think this is, okay, so we're actually going to take in a few other, or at least one other thing, because remember, we actually put in the enemy data, and we have our different enemy types that we're going to be having. So one of the things we have is a name, right, for the enemy. So we're just, yeah, name is fine, I guess. name will be string passed into the constructor. So when we create our new enemy, we're gonna go ahead. So this is creating it from the group itself, because remember this .enemies is the phaser game objects group. So what we're gonna do then is, wonder if we can pass in. So what does this function expect? This function expects, okay, this function actually, this is actually if we just want to, it creates a new game object. Okay, so basically I'm gonna guess what we want to do here is say, instead of creating a game object this way, we're gonna say new enemy, right? And we'll pass in the scene, which is this, the X, which is, how was that? Oh, enemy, oh, because we're creating, yeah, okay. We'll just actually do it here. New enemy equals new enemy. Again, this for the scene, enemy.x for the x coordinate, enemy.y. And you ever have that case when you're looking at a word too many times or spelling it too many times and it starts to look weird? Definitely happening now. Okay, so the monster info is giving us the sprite key, right? Because we're having that be dictated over here. So in our data array, we can dictate what different sprite keys we want to use for the different enemies. And remember, the sprite keys are used by Phaser to actually load, or they're used to associate the loaded image with a particular sprite. So up here, when we're loading our images into the game in our preload function, the key name of Goblin is associated with this image, which ends up being this image in the game. So that's how you link up the key name with the actual image within Phaser. So, all right, back to creating the player. So the last thing we need, right, is the name. So monsterinfo.name should be all we need there. Now we've created the new enemy, but, oh, so we don't need to do this. Oh, monster info is also, oh, okay, so actually, let's think about this a different way. So we also are passing in the HP with the monster info. The params list is starting to get a bit long. What I think I might just do is pass in the monster info, which is, I think we have an interface here. So let's actually export this interface from here. We will import what was it? We can from data monsters, and then we can say monster data. Okay, so we're gonna say that for monster info, we're just gonna pass in an instance of the monster data interface. And so this is just the data representing the name, the HP, the sprite key, and the enemy type of the monster. Okay, so we actually don't need the sprite key here because that's going to be grabbed from the monster info. So we want to pull a couple of things out of the monster info object. So let's get the sprite key, the HP, and the name, right, of the monster. So we are creating the monster there. We're going to set this.hp equal to the monster, its individual value of the HP, and we're going to say this.name, right, equals, and this.name might be something already on the object. Let's set this as it for now. And we'll see. Well, we don't want to set the velocity. Scene physics world, enable this. Okay, yep, so this should be everything we need. Remember, we don't want to set the velocity of the monster because it is not going to be moving. It's going to be stationary. So this is giving us an issue because we don't want the sprite key, and we don't want to pass it the string, we want to pass it the monster info. Okay, so we have the same issue that we had. Okay, so two issues, it looks like. Oh, of course. That's somewhat silly. This is not added to the world. Do we want, so the question I'm going to think about here is that, do we want to, inside the monster constructor, add it to the group, meaning we would pass in the group to the constructor and then add it there, or in our scene, take in the newly instantiated enemy and add it to the group there, which I think I'm going to opt for that because I don't think the enemy itself on an individual level should be responsible for adding itself to a group. I think it should just be managed on a higher level, if you want to call it that. So what we'll just do here is we can say this.enemies, I'm guessing add existing maybe, or maybe we don't have to say add existing. Maybe we can just say, okay, add an object in here. Okay, so that worked out okay. That is an issue because they're interacting via collision. So we want this to be static. So we set this dot body dot. Let's go ahead and do some Googling real quick. So we're gonna look for phaser 3, set object to be static, right? So let's see here, static. So we don't want static group. Oh, the body. So we have access to the body on the game object, right? So what does it have to say about static? Static counter for. So static counter is so the static body. So that's not exactly what we want. I want to see about if. Let's see here. No, that's not what we want there. It says static group. So I wonder if it makes more sense to leave it as a static group for the enemies. So let's just experiment. So this dot physics dot arcade dot static group, right? Static group, right? Okay. And then this dot enemies equals something, right? Enemies equal, yeah, okay. This dot add group. Oh, so this is. Oh yeah, of course. That makes sense. So this dot physics dot add static group, right? I think that's what it's looking for. So we still don't have the spray, but let's see if the collision actually works. No, it doesn't. Okay, interesting. Physical world enable this. Oh, so maybe we have to actually add scene dot add existing this. So if we add it into the world that way, that somewhat makes sense to me. Okay, so I believe what's happening here is that when we're adding it to the group here, we're just adding the instantiated enemy. It's not actually adding the sprite to the world. But when we handle it in here, it's actually adding the sprite to the world. Makes sense. Okay, now, it's not even colliding at all with the enemy. So that's interesting. Let's see here. I mean, here's our collision that's set up. We're enabling the physics, so there's the physics. I mean, you can see the collision box on it. Everybody's got their collision box, that's fine. I'm gonna bump up the player's velocity just so it moves a little bit faster, a little bit easier. Okay. Let's think about this here. Well, this is actually kind of weird because I have it now. Yeah, that's a game object. Accessing this. Okay. So. Add collider. It's a setup collision. I mean, when we look at enemies, setting up the collision. Yeah, static physics group, children. Yeah, there's 2 enemies in there. Okay, that's fine. This all seems to make sense. Let's look and see if anything stands out here. I'm not totally sure what I'm looking for exactly, but it does register as a static physics group. Okay, that's fine. On the body of this, does it have probably a static somewhere, right? I would assume. Is static maybe? Doesn't seem to be the case. Because it's not add. I wonder if it's not, but no, it is. It's adding them to the group. That's for sure. Allow drag, allow gravity. Phaser 3 collision not happening. See what some other Googling might get us. This looks like this is phaser 2. Very annoying. An arcade collision between a sprite and a group of. Okay. An array of groups. That's not what I necessarily want, but let's see what they've got. Add existing. So physics dot add existing, and we are doing that over here. Yeah, scene this physics dot. So I'm just gonna test something real quick, and I wonder if scene dot physics dot add existing this. If we add them to the physics now, okay, and then scene dot physics dot. I don't care about you. Let's turn it off. Do not disturb. Okay. Add existing this, right? Okay, so that clearly doesn't help anything. So they have collision boxes. Alright, they're not running together. Alright, so what else does this have? So add sprite, gravity, blah blah blah. Group. So add collider. Oh yeah, they're using an array there. Collide sprite physics group instead. So by using a normal groups, you ignore the benefits of static dynamic trees nebula and it's better rather get used to physics groups instead. Okay. Sprite? Okay. Just be sure this will work when passing any of these. A sprite that was physics enabled after creation, that's fine. That's essentially what we're doing, I believe. A single group as opposed to an array of groups. Okay. They also work with an array of physics groups too. So, I believe we're setting it up correctly. So what is the issue then? A static group, yeah, sure. That makes sense. And then when we create the enemy, blah, blah, blah. Enemies dot. Is there another method that might make sense here? Create, well, we definitely don't want to create anything. No, I would assume it does make sense to just add it. If we remove that. Okay, so I think what was happening here is I was kind of shooting myself in the foot. It looks like this was overriding the physics of the static physics group. So then our player was not colliding with it. That's what it seems like to me, at least. Obviously, it might be right or wrong, but we have it working where the player collides with the enemy. Cool, great, awesome. Now, okay, so let's just go say refactored. We're gonna commit here enemy to their own class. That's fine. And now we're gonna work on the actual combat between the player and the enemy. So let's make it so that our player can actually kill the enemy. All right. So in a previous session, we had this state where we're either moving, the player's either moving, or the player's in combat, right? And when do we get into combat? When we have a collision between the player and the enemy. So we set the state right here. And we want to handle the attack state. And just as a real quick recap, basically we have a cooldown timer that is decreased on every frame, right, with its delta time variable that's passed into the function. And basically we want to have the player and enemy attack each other when the cooldown's done. And when they attack each other, cooldown goes back on, and that happens. So actually, this could probably be simplified. This dot attack on cooldown. I can probably just say this if this dot attack cooldown timer is less than or equal to 0, right? Is that gonna work actually? No, because, well, yes, it should, right? No, that's silly. No, we'll keep it, yeah, we'll keep it that way. Let me think, what? Attack cooldown timer. I feel like I'm missing something simple, like an easier way to write this. Attack cooldown timer. If the attack cooldown timer is less than or equal to 0, then it should attack, right? Why is that? This dot attack cooldown timer equals 0. Nope. Let's see here. Else, this dot attack cooldown timer. Oh, because the cooldown timer is not actually set to anything, or it's no wait. Attack cooldown timer. Oh, it's not actually even a number yet, so that actually makes sense because it's not set up to be anything by default. So we can say this attack cooldown timer. You should be able to just say this, right? Yeah. Yeah, but that doesn't. Oh yeah, there you go. Okay, so it's actually going to wait to trigger. So let's set it to 0 so it triggers immediately. Okay, they attack each other. So you can see it here in the log, and it's populated in the same log message. Player and enemies attack each other. Okay, great. So let's go ahead and let's say, yeah, this is fine. So we don't need attack on cooldown anymore. Else, don't need that. That simplifies things quite a bit, actually, because that we might have to write that same logic elsewhere, and this is just a lot cleaner of a way to write it. Yeah, this makes way more sense. That was kind of silly. Okay, so handle attack. All right, so player and enemy attack each other. So what do we want to do? We want to have the player and enemy actually do damage to each other. Now we're gonna actually have some more information about the player. This dot attack equals 5 for now. Of course you don't type player. Public attack is a number on the player object. Okay, so we're gonna give the player a attack value of 5, and then the enemy we're gonna say, actually, let's go into the monsters and say, all right, attack value for you is that. We're gonna say on the interface that attack is gonna be a number, right? Oh, so this needs an attack, I believe. I'll give it an attack of 4. Okay, now TypeScript stop complaining. That's fine. So we're gonna get the monster's attack value from their actual data array element. So in the creation of the enemy, we're also gonna get the attack value. We're going to say this dot attack equals attack, right? Easy enough. Now, what are you complaining about? You need it declared here. Also, okay. All right. Now it's happy. That's good. And we can go back to our scene, and we're going to say, so one has to hit the other first in code. So let's have the player have the advantage and just say we're going to have the player attack the enemy. So how do we do this? This should theoretically be pretty easy. Oh, handle attack state though. We need to probably we could keep a reference to the engaged enemy. I think that sounds fine. So basically what we're gonna say here is private engaged enemy, right, is going to be an enemy. Now, what we're going to use this for is that when we collide with an enemy, okay, object, so player hit enemy. Object 2 is the object 2 is the enemy. Okay, I wanted to make sure in this callback that we got the right one between player and the enemy. So we'll say here that the engaged enemy is equal to object 2. And actually, we can just go ahead and probably rename this to player and rename this to enemy, right? Enemy. Yeah. Okay. Player, enemy. We don't even actually have to log that. Don't have to log that either. We know it's all working. Let's just get rid of that. What are you complaining about? Oh, because this is... That sort of makes sense. Because this is going to be... well, let's remove you, give you an underscore. That's just a typical convention for saying we don't need this variable in the function call, but we need to be able to access the second parameter in the function call, so we need to have something here. So we just put an underscore to say, hey, we're not using it. Anyway, I believe what this is saying is probably this is going to be a game object. Oh, wait. Is missing the properties from the type enemy? Yeah, okay. So this is just saying that we're passed in here a game object. Can we just say that we expect this to be an enemy? I think that should be fine. Because it is indeed an enemy which extends, right, the game object sprite. So I think that should be fine. So now we're engaged with an enemy. So we have a reference to it. This is important because in our attack state, we need to know which enemy we're attacking. And what we're going to do here is, let's see here. I'm always never sure of how to handle this and where to handle it. But what I think I'm going to do is for the enemy, let's create a public function called take damage. Right? This is going to just say this.hp minus equals the damage that we're going to take. So this gives us a way to interact with the enemy and damage it, lowering its HP. If, because we want to think about if it's going to die, if this .hp is less than or equal to 0, right, then let's create a private die function, then this dot die, right? Let's go ahead and make this an actual function. And we have just a destroy. All right, we have a destroy method. Let's see if that actually works. But anyway, so what this is doing is this is just setting up the functionality in order for us to be able to call this function, this public function, take damage on an enemy, and then be able to reduce the enemy's HP based on the damage that's coming in. And if the enemy has less than or equal to 0 HP, we want it to die. What's going to happen when it dies? Well, we're just going to call the destroy method. I think that probably just destroys the game object. We'll find out. So what we can do here is we can say, all right, this.engaged enemy is going to take some damage, right? Because our engaged enemy is just an instantiation of our enemy class. So how much damage are we going to have it take? This.player.attack, right? Because whenever we have a reference to the player, we can say how much damage it's going to dish out, and it'll deal that damage. Cool. Now, that worked. So what happened is that the player attacked the enemy enough to actually kill it. Now, what happens is it looks like the player's velocity is at 0 because it's only setting the velocity in the player constructor, I believe. So what we can do instead here, okay, so we're gonna have to switch a state. So let's say this.moving, we can say this.player.body.velocity.x equals 100, right? This should work, yeah. Okay, so what we're gonna do is basically, oh, that's interesting because our state should be changing though. Huh. It's not state.combat. That I find interesting. default case, just return. I actually want to debug that now because we should be in a different state. We should be in a combat state, which should stop our velocity. So theoretically, I wonder if, that's kind of interesting. Let's go ahead and just log this, set state, sure. It's gonna have a bajillion log messages. Oh, we need to, let's go ahead and, that's fine. So we're in state 0, which is, okay, no, we're in state 1, which is interesting. So I'm wondering what the difference is here then between adding the velocity inside of the constructor, which gets called once, which, remember, actually works, right? Let's stop. This will actually work. It'll have the player moving at a velocity initially. Boom, it hits in it. Is it going to prove me wrong now? What in the world happened before then? I must have seen something differently, or something changed. That's interesting though. Okay, that's fine, I suppose. All right, that's what now. Okay, what did I? Oh, I must have not. Okay, I must have not saved the file. That makes a bit more sense. So what is happening is that the velocity is set initially. It collides with the enemy, which kills the velocity. That makes sense, right? Let's actually kill that. And what ends up happening here, and let's get rid of some squiggles here while I'm thinking about it. And what happens is the velocity gets killed when it collides with the enemy, and then the velocity is never set once again. But my question is, why does case of state dot moving, right? Why does this work if I say player dot body dot velocity dot x equals 100? So why does this? We can take that out of the constructor. And why does this work after it collides? It's still setting the velocity. So let's verify that. Let's say setting velocity, right? I want to see if this is still being called when we're in our combat state. It is. Why is... Oh, because it just needs to... I don't think, right? That doesn't make any sense to me. Oh, am I a dope? Am I somehow a dope? But why... Huh. I must have just forgotten how switch statements worked for a second there. I guess what was happening is it was falling through to the next case statement and just running it, but that's kind of weird because I would have assumed that it wouldn't match that case, so it doesn't execute it, but clearly that's just a lack of understanding switch statements on my part. But okay, that's cool. That's exactly what I want to happen. I want it to stop because I want to revert the state back to moving once the enemy dies. So with take damage here, one thing we can do is return a Boolean, right? Return true, return false, right? What this is going to let us do then is that every time we see the, let me get rid of that log message. Every time we see that, or we have the enemy take damage in our scene, we're going to be able to know if it died, if the enemy died. So const enemy died is that, and so if enemy died, we're going to set this dot state equals state dot moving. So all this is doing, I can get rid of some more log messages. All this is going to do is theoretically, once the enemy dies, it's going to return the state to moving, which is setting our velocity to 100 again. Boom, we're moving along. That's great. Okay, awesome. Perfect, perfect, perfect. So that's working properly. Now, let's have the player take their damage, because they need to be hurt as well. So let's do this the same way, I think, right? So let's go ahead and say public take damage, which is a number, right? And return a Boolean if the player died or not, right? So this dot, and I can just copy this from here. Okay. I'm going to say private die. Maybe we want this to be handled differently because it's the player in the future, but for now, whatever, it's fine. But what we can say then here is const player died equals this dot player, right? Dot take damage. What damage are we going to take? This dot engaged enemy dot attack. So, what we'll say here is we'll have some messages. Player took damage. Current HP is this dot HP, and we're saying the enemy console.log enemy took damage. Current HP this dot HP, right? So what this init already did show us is that, okay, player and the enemy, they're each taking damage. That's fine. Working out properly. The player's still taking damage. That's great. Okay. So let's go ahead. Let's go ahead and actually give the player just like 4 HP or something, just to make sure that the die function works on the player. Okay, took damage, blah, blah, blah. Boom. Okay. Yep, and it can't read velocity on fine. That's fine. Ideally, what we should do is have a new state, like player died, if that's the state that we're in. So let's think about what we want to do here now. I think we probably want some visuals here. Maybe we have some text above the sprites for how much HP they have if they're in combat. Yeah, let's work on some GUI stuff. All right, so for our source control, we're gonna commit and say that player and enemy now can attack each other. Sure. I'm just gonna push that as well. Always keep things under source control, basically no matter what. So what we're gonna do is let's look at some phaser stuff for how to put text. Oh, we don't need that either. I think that should still work, right? That was a variable we were not using. Yep, okay, that's fine. Player can return back to having, give a decent amount of HP. Phaser B text above sprite. Alright, text, center text on sprite. Okay, that's essentially what we want to do. Ah, shoot, this is the old one. Anchors, okay, blah, 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 game that sprite. So we might be able to kind of extrapolate what is happening here into phaser 3, but this is basically adding text on a sprite style, game.add.text, text.anchor.set. Definitely missing something here. Sprite.with, no, that's just saying wrap it around. When you get to that, why is that working? Alright, let's look at the phaser 3 examples. And this is a lot of what your coding is always going to be, is looking through either examples, documentation, or somebody else's question that has the same problem as you. Let's see here. Games. Is that full game? Oh, that actually might be useful to take a look at. So we'll depth sorting eventually. I don't have anything specifically about that, so let's just look for the text up here. Display tint text. I don't care about text tint. Game out static text origin, maybe. Text to render texture. Blah 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 blah. Change text. Static. Well, I definitely want to go on the game objects folder here. Test text. All right, here you go. Static. Sure, I guess. Align text. Create from config. Italics. Right origin. Left right. Text bounds. Well, let's just see how to create it first. Okay, this dot add dot text. basic text is probably just, yeah, font family, whatever, that's fine. But if we want to anchor it to the sprite, I'm surprised it doesn't have anything about anchoring. I'm probably missing something, but maybe text origin is what we want? No, that's not what I want. Let's test. All right, let's see if... I wonder if we could actually just have it in the player's class. Can we add the text there? I mean, we can definitely add the text there. I just want to see how you can anchor it. So it should be it's just a game object, right? When you look here, does that add text? So if we wanted to say scene.add.text, right? What does this return? This returns game objects text, sure. And this is okay. Just looking through the actual TypeScript documentation to see if there might be something here. Text resolution, padding, height, canvas texture, blah blah blah, blah blah blah. This is where we're at. Set text, that's now set font family. All definitely useful, but nothing we want for set align. No. Set padding, no. Update text to JSON. Obviously missing something. Alpha. Display width, set size, set display size. Set, Anchor? Yep. No, I don't believe that's what we want. So, phaser 3 anchor game objects together. And this is another second one. Well, let's see here. No, that's not what we want. Spread anchor. So I wonder if actually we have this update function, right? That gets called for any of our game objects, right? So what if we wanted to say public HP text, right? It's going to be phaser.gameObjects.text, right? That's what it's going to be. And we're going to create it here, so we can say this.hp text equals say scene.add.text, right? And then we can say this. Actually, we already have the x and y. Maybe we'll say like y plus 20 just to raise it above and see if that works. Test. And I don't necessarily care about the style for right now. But what I'm guessing this is going to do, yeah, okay. So that obviously does not anchor it to the player. That makes sense though. Let's just do this again and figure out, save the file. Yeah, that's just farther. Okay, so I have my directions wrong. So 20 might be too much, but let's see here. Okay, so that'll actually be pretty close to above the player. So this is probably crude and probably not super great, but I'm gonna try it and we'll see if this actually works. HP text. Can you set like the actual position of it? Name origin path. No, you can set position. Let's just see if there's anything else here that makes sense. No. Set align, set, yeah. Anchor. Nope. Okay. So set position, and we can say this dot x, this dot y minus 20, right? Oop. Come on. Okay. Interesting. Okay. make sure this is being called player update function. So what I thought this would do is just update the, so it's not actually calling, I figured that it would automatically call that. That's kind of interesting. Do we have to call it from here? Like, I think this will work if we just call, actually, just default break, we don't want to return. I think if we just say player update, right? That should definitely work. Yeah, I mean, that moves the text with the player just fine. We can probably go ahead and get rid of these boxes, which I believe are set up. Some, phaser free show collision box. Okay. Enable debug showing sprite collision boxes. Okay. Just forgetting how to do it. Oh, debug in the actual creation of it. Okay, okay. So, and I don't even remember what file that's, I guess, in game. Yep. So, let's say debug is equal to false. Okay, cool. I got rid of the boxes there. That's fine. All right. So, that's seems like a crude way to do it for having the player keep the text that way. But I'm going to leave it just because it's working, and I'd rather have something working than not have something working. So what's happening here is that, remember, the update function for our scene gets called on every frame that's rendered in the browser. And what ends up happening is we're just calling the update function of our player. And in our player function, we're saying, okay, set the position of the HP text, which is above our player, to be basically on the same player's position, except move its Y coordinate up 20 pixels. And apparently we probably need to move it over to the, over on the X a little bit, but let's actually set it to the proper value. It should be this .hp and toString, right? Because it's TypeScript and we need to be safe about all our types. That's proper. Of course, it's not being updated, right? Because it's not. This is only being called once during the constructor. So during the update, we want to say this set the position, but also hp text.set text. Yep. Okay. This .hp.toString. Okay. So now when we take damage in the update function, we're handling it here. So boom, we took damage. Now, okay, great. Now our text actually changes. That's fine. So let's actually style this a little bit. I'm just gonna give the, actually I wonder if we can, if I just comment this out just for debug purposes so I can keep everything on the screen. Yeah, okay, we'll just leave that for now. All right, so for this, where am I looking here? Wrong class. For this text, let's go ahead and say font. No autocomplete for this. That's a bummer. Oh, because it's just an object, it says here. All right, well, let's go back to our Phaser 3 examples. And let's see what kind of options we have with the text styling. So game objects, text, static, sure, whatever, I don't care. From config, wonder if we want to do, they didn't have something about, yeah, web font, yep. Now, is this loading it from an actual website URL access? Okay. Oh, what I think we might want to do then is actually bring in a nice pixel font. There was one that I was using before. Pixel font download. Let's see what's here. I mean, whatever this is looks okay. Minecraft lettering. It's a bit clearer, this one. A lot of downloads, free. All right, let's do it then. We'll just download it, and what we're gonna do here is let's see what it gives us. Just a TTF file. Okay, cool. Into our Twitch game it shall go. So fonts, put it right in here. I'm just gonna call it Pixel Mono. Obviously that's not the name, but just an easier name to type in there. Now, what we're gonna say then is let's follow the example here, right? So styles, so this is basically CSS, it looks like, setting the font face and everything like that. All right, so text, HP text style, right? And then we're gonna say that the font face, font family is going to be mono, mono pixel, right? That's what I think I called it. And the source of this is going to be a URL that is in Oh, this is insert. Oh, okay. I didn't even see what it was doing here. All right, so the way this is working is that it is literally getting the style sheet and inserting the CSS. Okay, that's fine. So what we want to do actually is, yeah, okay, that's fine. So actually, we're not going to handle this in the players yet. What we're going to do is take this. Sorry, I had to sneeze for a second there. Okay, so in the scene, what we're gonna do is in the preload, load in the CSS needed for fonts, right? So you can paste that back in, and we'll say font styles. So the font face, blah blah blah. That's fine. So I think, I don't know about if we need a absolute path to this or not. Fonts, and it is referred to as Pixel Mono, that's right. Fonts, Pixel Mono dot TTF, and then TTF format, format CSS. I don't know what the format actually needs to be. Oh, true type, okay. So let's see, go back to our example. Okay, so that's the URL, right? And then the format, true type. Let's just close this off for now. I believe that is, I think, oh no, I didn't screw up here. But let's actually go over here and we'll say font family, yep, that's fine. Oh, I didn't close the bracket there. Have the semicolon. I believe actually CSS needs that. And then so we'll get the sheet here. So we're gonna say const sheet, or what's the element? Create, oh, so it's literally just actually creating an element. Okay, that's fine. Element, document.create elements, create a style element, that's fine. Document.head, append child, right? Yep, child style element. So we're just appending this new node that we're creating actually inside the HTML. So element.sheet, so const sheet equals style element.sheet, right? So now we're referencing the actual sheet, the style sheet there. I'm gonna say sheet.insert. What's it complaining about here? What am I missing here? What did I do? Oh, well that was silly. I think I didn't need, yeah. This is not a object, it's just a string, of course. So we should be saying then sheet.insert rule, font styles. Apparently that's a thing. Type style sheet. Insert rule does not exist on type style sheet. Insert rule does not exist on type style sheet. So let's see what this is complaining. Add rule does not exist on type. Okay, that's the same problem I have. Is besides is really missing add rule. This method is defined in CSS style sheet. You can use okay, blah 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 by forcing adding type to string and then add okay. Okay, style sheet as okay. Okay, okay. Not sheets. Sheet as CSS style sheet. Right, should be able to do that, I think. Okay, that makes sense at least. So we're just saying this was a TypeScript issue where basically it was saying that the style sheet object did not have an insert rule method on it, but in actuality the CSS style sheet does, which I guess is what's inheriting. Style sheet's inheriting from, maybe not, but essentially that allowed us to call the method on the style sheet and insert our font styles. So that's good. So now we have monopixel as a font family. So inside our player, what we're going to do is go ahead and say blah 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 here in our styles here. We're going to say fonts, yeah, family. Pixel mono, right? Okay. Now let's actually see if that's working. It doesn't seem like it is. That looks not like the right font. Is if it can't find the font, it falls back to a default. Yeah, that's definitely the default. That doesn't look quite right to me. So let me try a built-in Arial or Arial maybe. No, that works. So that sets it to that font. That's fine. I think that's okay for now. We're gonna leave it as that. We'll come back to the fonts probably next time. But let's actually just adjust the x coordinate of the. Oh, we need to change it in the update function as well. We could probably make that a little bit cleaner. Yep. Okay. So that's just about right. Maybe 8 pixels instead. Yeah, that looks pretty good. And honestly, we don't even have to worry about this because the first frame is just going to get updated to the proper position anyway. So that's fine. What we should be doing is probably end up having this be a bar anyway, but we can figure that out later. So I think it's a good place to break. And so let's go over what we actually accomplished. And let's actually take out the comment we made in the scene to handle the attack. So we actually fixed everything with our player. We extracted or refactored the enemy to be in its own class. We ended up actually moving the player to not be a arcade physics object, but rather a game object that has physics enabled on it. And we actually got the combat working. So players can damage enemies and enemies can damage players. And the player keeps on moving, switching between this state of combat or moving. So we got all that done. I think we might work on a little bit more visual stuff next time. Actually, the first thing we'll work on next time we'll be reaching the end of this level of dungeon. That'll be good, and we can get that going. And then we might work on a little bit more visual stuff in terms of maybe we'll have the health bar, and we can actually work on traversing to a new dungeon level and going through there, maybe keeping track of some experience and getting some loot and all that kind of stuff. Then after that, we're going to actually go to the Twitch integration. So we'll actually work and figure out how we can use the Twitch API to get the people that are in chat and have them actually have that feed the data into the game as far as what players running through the dungeon and etc. So thanks for watching. I hope you maybe learned something, and I will see you next time.